Okay, pre-calc. Here's part 2 of the notes for section 7-4. I'll put it at the top here. 7-4, part 2. Part 2 of the notes now. 7-4, part 2. All right, I don't like that marker. Let me get a different marker here. Graph y equals 1/2. Now, the 1/2 changes the amplitude. It just means the curves going up and down are going to be a little bit lower than what they normally are. What's the period length? The period length, because the multiplier in front of x is still 1, it doesn't change. It's going to stay just 2 pi. It's just going to stay 2 pi. What's the distance? So between key x values, that's the interval length. All right, what are the intervals is what it's based. I'm going to ask you, what are the intervals? The intervals are those key numbers in between. You take 2 pi and you divide that by 4 into 4 equal parts. And so each one of those is going to be pi over 2. Pi over 2. Take what's in the parentheses. So in this case, looks like they had the wrong number there or something like that. You're going to take x minus pi over 3. Going to set it equal to 0 and determine your starting point. So let's do that down below here. X minus pi over 3 equals 0. Add pi over 3 to the other side. Well, they're making it really easy. So it's going to shift to the right. My starting point's at pi over 3. Shifts pi over 3 to the right. Everything shifts pi over 3 to the right. So it's a sine curve, but instead of starting at 0, 0, it's going to start at pi over 3. It's going to be a length of 2 pi. So what you need to do, we got to do our scratch work down below here. It's going to start at pi over 3. The interval, it's going to go up by pi over 2 from that. I need a common denominator. So we're going to make it 2 pi over 6 and 3 pi over 6. If you add those together, you get 5 pi over 6. And that's my next critical point, 5 pi over 6. Now we're going to add to that pi over 2. Common denominator would be a 6. So we're going to make it 3 pi over 6. This will make it 8 pi over 6. So we're going to write 4 pi over 3. You must reduce it. It has to be reduced. Looks like we can pick up a pattern. 3, 6, 3. It must be 6, then 3. That must be what's going on here. So I'm going to leave it 8 pi over 6. If you wrote it as 4 pi over 3, I have a feeling 6 is going to be the common denominator that we need. We're going to add to that pi over 2 again. Yep, common denominator we need is a 6. So we're going to make it 3 pi over 6. That can give me 11 pi over 6. 11 pi over 6. I feel like we did this on the other page. And then pi over 2, make it 3 pi over 6. That's going to make it 14 pi over 6. Common denominator stays the same. That's going to make it 7 pi over 3. 7 pi over 3. So you got some awkward looking answers in there. Once you do that, it really is the toughest part of the whole thing. Once you do that, it's just making your sine wave. Now remember, a sine wave looks like this. That's what a sine wave looks like. It's going to start here. If this is 1, then it's only going to go up a half. All right, let's say half is about right here. And if this is -1, it's only going to go down -1/2. So it goes here, then here, then here, then down, put over here, -1/2, and then back up. And that's my little sine wave. Well, we didn't move anything up and down yet. Oh, it's on the next level. So if you do everything that we've been doing, and then they add or subtract a number. So we're used to seeing it after it, but this is actually quite common where they put it in front. But basically, we're going to graph 3 cosine 2x, and we're going to move our x-axis. Everything's going to shift 2 up. Everything's going to go up 2. So I'm going to box this right here. Adding 2 outside the operation shifts your graph in what direction? It goes up 2. All right, everything's going to go up 2. You could show this with a dashed line. That's actually a good idea. We're going to treat that like our x-axis. So where the x-axis has been like the middle of our graphs going left and right, we're going to make at the 2 line, we're going to make a little dotted line. That's where it's going to be. So my amplitude is a 3. You're going to, from the dotted line, you're going to go 3 up from that. 1, 2, 3. That's 5 now. That's going to be the highest number. And the lowest number is 3 below the dotted line. 1, 2, 3. -1. So what that means is my range, probably important to do that. My range is going to go from -1 to +5 for the graph. It's going to go as low as -1 and as high as 5, because ordinarily it would have been as tall as 3 and as low as -3, but those got shifted up too. 2 up from -3 is -1, and 2 up from +3 is +5. What's the period length? So you got to take the number in front, that's your b value here. You're going to take 2 pi divided by 2, and my answer is pi. What's my starting point? All right, that's a question we got to do. 2x is here. You have to take 2x and set that equal to 0. All right, there's no parentheses, but you could put parentheses around that. If 2x equals 0, all I got to do is divide by 2. My starting point is 0. Well, I made that one kind of easy, to be honest. What's the distance between your key values? So intervals, you take the period number and divide that by 4. And so it's going to be pi over 4. Pi over 4 in between. So this one actually is a little bit on the easier side. It's more like the last section. We're going to start at 0, and it's going to end at 1, 2, 3, 4, 5. It's going to end at, not 2 pi, I'm sorry. It's going to end at pi, whatever the period length is, because we started at 0. There was no shifting left and right. If it was going to shift left and right, instead of just having 2x, it could have like 2x plus 3, and then everything would shift 3 to the left. Actually, that would be 3. It'd be like pi over 3. Everything would shift pi over 3 to the left. They didn't do it. They didn't do it that time. All right, so it's just going to stay starting at 0, ending at pi. Intervals of pi over 4. So this is 1 pi over 4. This is 2 pi over 4. So-called pi over 2. The next one's going to be 3 pi over 4. I might have put this at the wrong spot here. 1, 2, 3, 4. Yeah, I did. I got one too many lines out here. Sorry, guys. And that's going to be pi. All right, now our graph is going to be cosine graph. So that's where it starts at the max, does one of these. All right, it's not flipped upside down. If they want to flip it upside down, the amplitude number would have a negative sign. So we would say it's something like 2 minus 3. Then that would flip it upside down. All right, now let's see here. So on the y-axis, I'm going to start at 5. All right, that's the highest, that's the maximum. Then it's going to hit the middle. What normally would have been the x-axis, we're going to say is right here. All right, the next point, it's going to hit the minimum, and then it's going to be at pi over 2. It's going to hit the minimum right here. At 3 pi over 4, we're back to that midline. And then at pi, we're all the way up here. And the graph looks like this. That's my cosine graph, all right, with an amplitude of 3. So from the dotted line, we go 3 up and 3 down. And everything was shifted up 2. All right, last bit of notes, guys. So for y equals, and they just put a generic d, letter A, multiplied sine, letter B, letter C. Each part does something to your graph. A is the amplitude. All right, A is the amplitude. How high up or down from that dotted midline. Now, most times it's the x-axis, but this one, it moved up. So how far down do you go and how far up do you go from that midline? B helps determine the period. So you take period length, all right, and you divide that by b. So right now, it's been 2 pi divided by b. The normal period length, I should say normal. You take the normal period length and you divide it by that multiplier of b, that b that's in front of x. Shift your graph horizontally. To make it shift left and right, all right, that means left, right shift. To make it go left and right, you take the parentheses, set it equal to 0 to find the start. Whatever's in the parentheses, all right, set that equal to 0, solve it, and that'll give you where it all starts, and that'll tell you, hey, did it shift left or did it shift right? To shift it vertically, all right, you need to move the midline. All right, I'm calling it the midline, up or down. And that's when you add or subtract in that D location. They usually put it in front, but every once in a while you see it after. It'll say plus D after it. It'll just be some number like this number 2 that was in this graph up above. All right, guys, that wraps up section 7-4. It does make it a little more complicated than what we learned in 7.3. Hopefully with a little bit of practice, we'll get better at it. I think the biggest issue might be trying to find those 5 critical points. Find the interval and keep adding it and knowing how to quickly add and subtract fractions without having to grab your calculator every time. All right, guys, if you have any questions, let me know.